Good afternoon, good morning, good evening, depending where you're joining us from. My name is Colin Domoney. I'm going to be presenting a webinar on the breaches in the second half of 2022. Firstly, just by way of introductions, those that don't know me, I head up the security research at 42 Crunch, and I'm also the developer advocate. And most importantly, I edit the APIsecurity.io weekly newsletter. And what we're going to be doing in this webinar is we're going to be featuring many of the vulnerabilities that we've seen in the last half of this year. And what I do to frame the discussion is around what we call our security framework. So how are we thinking about API security? So firstly, a note on the vulnerabilities that we're going to cover, right? People make mistakes. Mistakes happen to everyone. They can be very costly, as we'll see. Mistakes are, however, a learning opportunity, and that's really what this webinar is about, right? So you can learn from the problems that other people have had, and how to make sure that you don't fall victim to that yourself. And importantly, mistakes can often be easily detected, and we've got plenty of examples of things that really should never have made it to production. All right, so what is API security? So we're obviously familiar with the OWASP API security top 10, but it's more than that. There's API abuse cases. There's business logic vulnerabilities. We look on the top of that, we've got a governance process and an inventory. An example of governance is, are you checking that your APIs have the right security controls? We've got an example where, that just never happened. And then you've got your coding skills, your coding flaws that you have, secrets management, and you've got your libraries and operating system vulnerabilities. So there's a lot to API security. So not everything that we're going to cover in this webinar is API specific, but it would have affected API. So we just see how broad a topic API security really is. Now, 42 Crunch's view, my view is that good API security practice is built on a layered model. You normally have a good DevOps process to be able to build reliable, repeatable software. You have your standard source code control things. You have your SAST, your DAST. You have your API management and gateways, and then a API-specific security platform. And then sitting over that, you have API governance. Now, the reason I'm going through that preamble is what I do is, if you've been on the previous session that we've had like this, I break up the fault analysis. So what I'm going to do is I'm going to present a flaw to you, explain what happened, a vulnerability, and then we're going to do a little bit of a dissection of that, right, to work out where the developers, where the organization could have done better. And I break it into those 6 broad domains: inventory, design, development, testing, protection, governance. Just a way of kind of framing the problem and thinking about the problem. Let's start looking at the vulnerabilities that we've seen in the second half of the year. So the big one, I do keep the names out of the report. Well, I intend to. This is a big one that happened to an Australian telco company a while back. There is some mixed information on what happened, but what it would seem like is that there was a public API in the first instance, so an API that was on their root domain, but kind of hidden. So it wasn't advertised, but obviously attackers could still discover this. Unfortunately, it also didn't have any authentication whatsoever. And then even worse than that, backing behind that on the data was, highly sensitive customer information. So driver's licenses, phone numbers, passport details, dates of birth, etc. So the impact of this vulnerability, and I'm pretty sure most people who have seen this in the news, the impact was massive, right, for the organization. So as far as reputational, this is probably the worst you could have as reputational damage. So Australia, they managed to divulge to the PII of 10 million customers. That's 40% of the country. And the total running cost at the moment are estimated at 140 million Australian dollars. So it's pretty severe. The causes: lack of authentication, leakage of excessive information exposure, leakage of data. And then the other thing that they did is on that API, the customer numbers were guessable. So even if you didn't know what customer number you were looking for, you could just iterate through that. And the lessons learned, bit of a glib statement, but numerous and painful. These guys had a lot of trouble with this one. So where did we go wrong here? So I'm going to jump ahead and look at governance. That's the obvious biggest failure. This API should never have been deployed. Even in the first instance, if it was, it should have had security controls and security measures on that. And obviously, there was no understanding of what constituted sensitive customer information. And then we come back to design, that failure to understand your PII requirements, leaking customer details. I don't know whether they, with the root cause of this is, did they ever intend to put this on the internet? And if so, why weren't security requirements captured? Maybe they relied on security by just having a hidden URL. But anyway, as we've seen, that certainly didn't work out for them. The developers, whether intentionally or accidentally, just had no attempt was made to try and protect. If you wanted to make this public data, you couldn't have done a better job of it. Their testing, again, whatever their QA test release process, it didn't detect any of these things. They were doing no network scanning. It waited until it was a major breach till they understood what was going on. So the next one is a popular social media platform that's been in the news recently with their new ownership that they've undergone. And there's recent news in the last year of an attack that's been going on where cyber criminal group have been trading user data on this platform. Up to 5.4 million users are affected. And what's happening here is that the platform exposes a search user's endpoint to go and discover new users. And what the cyber criminals were able to establish is that there's an attack vector. We'll look at the attack vector in the next slide, whereby they could actually go and leak user information. So what they were able to do is they were able to establish yes or no, does this person have an account on the platform? And actually, in this case, that was all that was needed to know, right? So they could get a positive confirmation, and once you've got that, then they've got the data for a spear phishing attack, right? Which they can make pretty targeted. Reputational damage. Well, I'm not sure the APIs are the leading cause of reputational damage at the moment, but yeah, obviously the platform was severely affected from that. Root cause: exposing a helpful API that has an adverse side effect and can be abused. Excessive information exposure. The lessons learned, again, be aware of these unauthenticated APIs. Even if you think you know what you're doing, they might seem benign, but they can often be used kind of against you in a way that you weren't expecting. The lessons learned, how to solve this, is those unauthenticated APIs, and then always do the standard minimal implementation of an error handler. Let's just jump forward to what actually happened. So the details of what happened is there was an API that had this, we go to the design there, a search users function. And what the attacker found was that if you called the user and you guessed an email address and you didn't authenticate, because obviously you didn't have the password, you would get a response. Now, if the user didn't exist, you would get a 400 with a particular type of message body. But if the user existed and you failed to authenticate, so it would have been a 403, you got a message body, and in that message body was the email address and the user's telephone number, right? Even though there was an error. So they found that the attackers found that they could go and mine all of this very fairly sensitive PII data against an endpoint. Right, so pretty bad there. Now, the main problem here from a development point of view is those developers should have coded that so that all error codes would not return that excessive information, right? Just to return something that says login failed or query failed. The testing, they could have tested that. They didn't detect that in protection. So the fact that they were able to exfiltrate 5.4 million records, indicates that they probably weren't terribly well rate limited. They could have reduced the scale of that impact by implementing rate limiting. Right, moving on to the next one is crypto trading platform. So the actual details on this, obviously for confidentiality reasons, but it looks like what happened here was that there was a third-party API, a trading bot. The trading bot was authenticated to be able to connect to various platforms. And what happened is that the bot started making trades on behalf of users, right? And there's rumors. This is all rumors and speculation. There's no hard data on this, but that and this has also been in the news. I think it actually was in the news today that one of the founders of one of these organizations has been arrested. It could have resulted in unconfirmed losses, and in some cases, the platforms actually withdrew people's ability to withdraw their own funds. So it's a pretty severe loss of investor faith in the cryptocurrency market. Make your own joke there. And the scrutiny of regulators, the cause, leakage of third parties. It was either leakage or theft, and that's where the kind of jury's still out on that. But the moment you create a long-lived key with credentials to you delegating access to that, and if you don't have any means to revoke that, you're opening yourself up for a lot of damage. That's just some of the back and forwards on this. People, I've lost 450K US dollars, and it's still ongoing. That's just pulled yesterday off the internet. So crypto trading platform, what's the root cause there? API keys, right? Or the lack of management of API keys. So the next vulnerability is a Helpdesk ticketing system. This is one of these enterprise style platforms that we have. What happened here is that the platform they used a new GraphQL endpoint, which is great. GraphQL offers you lots of opportunities for developers. So they use GraphQL, and this is the first instance I've seen in my time of an SQL injection. So they actually had a live SQL injection against that endpoint. And the proof of leakage could show that user data was leaked via this injection. No damage done because the researchers found this and disclosed it immediately. The root cause, it's a friend SQL injection, 21 years and counting. Lessons learned, these are basic lessons. Well, the first one is sanitize all user input in the context of your data sync. And just remember that GraphQL is a complex beast, and you need to understand those security implications. What were the issues here? So design, maybe they could have understood the threat vectors apparent on GraphQL. They failed to use standard protection. So one of the great things about SQL injection having been around that long, we know how to protect against that, the standard things. And also SQL injection can nearly always be detected by either penetration testing or even better with static code analysis early on in the life cycle. And they could have protected SQL payloads. WAFs do a sort of reasonable job. There's API dedicated firewalls that do a really great job. And obviously 42 Crunch, that's one of the products in the portfolio. So this shouldn't have happened, or if it did happen, we should have been able to prevent this. We will share this, and all the detail is written up in the APIsecurity.io newsletter as well. So coming on to an issue, this is again where the API itself is not to blame. Is not at fault, but it shows the damage that can be done by leaking API credentials. So this is a case of a very well-known, probably the original file hosting service, so cloud storage service. And it was a phishing attack leveraged against the developers within this organization. And what they did is they managed to phish those users, so the developers who were logged in via their CI/CD system. It was Circle CI, and that wasn't the issue here either. They had a Circle CI account which was connected to GitHub. The user phished the developers by giving them a email that looked like a reset request for Circle CI, but it wasn't. It gave them access to the Circle CI platform. They then stole the GitHub credential, and then they had access to the GitHub repos, right? So dead simple phishing attack, but now leveraged against your backend API and CI/CD systems. No damage was done here because of so GitHub actually detected this, right? GitHub saw what to them looked like unusual activity on the repos, on that particular set of repos, and flagged this. So an outstanding job on the part of GitHub being able to detect that. I'm not going to talk about phishing emails in any great depth, but just when we come back to this point of hold this thought in your mind, those API tokens, they be forming an increasingly important part of your supply chain, right? Treat them as you would, your your key to the building or your access pass, right? Where did we fail here? So they probably didn't think about what their token access policy looked like. They certainly didn't detect the phishing attack, which is odd, because that should have been obvious to detect. And the fact that then they had to go and rotate and revoke all those tokens. And the tokens in this case were found to have fairly wide open access. So that it meant that they just blanket had to go and revoke all of them. So they didn't have an expiry set. They didn't have they didn't limit the user scope, right? So pretty bad governance around the issuance and use of tokens. And protection just shows the value of partnering with somebody is really on the front line of being able to deal with that. So question here, so this file hosting service attack, yes. So would two-factor? Yes, it would have. Yeah, absolutely. Yeah, Alex, it certainly would have. Because then they would have, the person, when they got the two-factor request, they would have gone, yeah, hold on, I didn't request to set my password. Why is that happening? So yeah, cool. Thanks for that. Now we go on to this same popular social media platform. Their second feature today. This time it's not something they did wrong. This was a case of, again, API keys. Remember I said we're going to see this a lot in this session. Those API keys were leaked. This was access tokens. So people developing third-party apps that go through the whole process, they register the app. And we're talking things that are going to be using the social media platform on your behalf. So any of these things that can cross-post and that like, they all have an access token. Now, what happened is researchers discovered that there were over 3,200 public instances or locations of leaked platform keys to the social media platform. And the way that they detected this is they just found it hard-coded into consumer apps. Now, there was no known abuse or impact because people started revoking and rotating keys and tokens. But the problem here is that attack could have been quite significant, particularly in our current sort of socio-political environment, because that could have allowed a massive, absolutely massive distributed bot activity against that platform. The fact that you would have had these keys from various apps, it would have been very hard to kind of get to the bottom, the root cause of what was going on. So, potentially quite impactful. The cause here is hard-coded keys again, and lack of that robust key management rotation policy. And the obvious ones here, lessons learned, don't hard-code the keys. And if you're a provider, so this is a case where the impact was actually the platform itself. As a provider, make sure that you can detect those, get your threat intel going. Try and find out when you're seeing keys that being maybe used in multiple locations, anything that would indicate some sort of compromise. And really, this from the consuming side, so the API clients, that's bad practice, right? They didn't design that key handling properly. They should never have stored those credentials and code, and it could have easily been detected and tested. Right, it's very easy to spot these things in production. So it may be a case of the client developers just didn't bother about this. They just took a shortcut, right? That's one of the reasons we often have insecure software. So a data center management platform, let me just give you a clue what we're talking about here. These sort of portals, when you register with an ISP or a service provider or a hosting provider, you get these unified consoles, lovely clicky GUI things that allow you to do control everything under the sun. And these are great, centralized management that can automate. But the problem is underlying that there's really an internal API doing the heavy work. Now, there's a good story on this one. So we spoke with Jim Manico, did a webinar with us about a month ago on cross-site request forgery on APIs. And I went looking for a recent example, and I couldn't find one in the last year or two. And then literally the next day, this news broke that this is exactly what had happened. So the attack, and this came from our friends, a research company in London, Fortbridge, who featured with us before. Great work here in exposing this issue and really going to some great lengths to exploit it. And the exploit was non-trivial, conceptually easy, but in practice was very difficult. And what they found was, I'm just going to skip forward a slide and then we'll come back to this. So what they noticed first is that there's a cross-origin request policy. So they wildcarded that. That's a no-no. And then that allowed them to go and do a load of manipulation where they were able to go and steal the authentication token. There's the basic auth token there. You can see that red widget. And they could steal that, and then they can go and do arbitrary commands using the web token on the API, right? And they could go and do things like they could go and add a database user, they could go and add an FTP user, and then obviously what they found they could do is they could go and change the admin's password, and you can see the password update, right? And at that stage, all bets are off. They've got total ownership of the system. So let's just come back to the underlying issues, what these guys did wrong. So they used an API that was vulnerable to CSRF. There's very well-known patterns on how to protect this. Jim Manico describes 2 of them in the webinar. You should not fall foul of this, and this is increasingly going to happen as people build on top of APIs. Right? You might think that those APIs are hidden, but of course they're not. They publicly, if you can get to the UI, they're publicly visible, and people really need to go back to old school and understand how these old style web attacks happen. Okay, so not a lot to write on this. So this would have been quite hard to protect, to be honest, with normal API, normal security tools. It really came down to good design and understanding that threat method. Load balancing appliance. So not as soon as we'd had that cross-site request forgery, about 3 days later, this news broke. So a well-known load balancing appliance. Researchers discovered exactly the same thing. I'm not doing this in detail because it literally is verbatim the same attack. So somebody worked out they could be, if they had a logged in session, they could go and steal that web access token and then use that to access the APIs. And just to show you the danger of these type of attacks. So this I noticed in doing the research for this, there were within 25 days, and that's actually live today, there was already a Metasploit exploit available in the public domain to go and exploit this. If you don't know what Metasploit is, it's one of the cool tools that people throw up against their targets to go and exploit them. Same concerns there. Just understand the basics of how the old school web application security works. Right, community platforms. So finally, 9 issues into this, we come across our one and only occurrence of BOLA, broken object level authorization. So here a security researcher was messing around with the web interface of a community platform, popular Q&A platform, and they discovered that they could go and access the logs of other forums by simply manipulating the forum ID. Right, they didn't have access to the forum, but on the API they could just go and twiddle the forum ID. So that's BOLA, very simple case of BOLA, and they were able to access that. So minimal impact. What do we learn about BOLA? We'll look at the best practice for BOLA in a mo, but basically never trust users' applied parameters, and always fully validate your access to those resources. That's just showing an example. The API was taking an ID parameter, which is always a clue to an attacker on what they should be doing next. Threat modeling would have probably identified that, but this comes down to training developers. And in this case, you would have been able to detect that. 42 Crunch is soon going to have BOLA support. There will be a webinar it's going to break early new year, where we're going to take you through how we can detect and protect against BOLA. Right, and this is a particularly simple case where this could have been protected, testing or runtime. Right, second last of the issues. So again, this is exactly the same as the social media platform, which I nearly named there. Exactly the same issue. So third-party clients consuming the service from the platform, they used keys which were embedded. Those keys then leaked, right? So then we had a problem. We had to rotate things. It's exactly the same. This is exactly the same as the other one. never hard code keys be able to protect those. So let's have a look at just the sort of impact, the range of consumer applications. So there were 3,200 different applications, and that's the number of users affected. Right, so pretty impactful vulnerability that. There's one addendum that I want to make on the development on this. So if you have an API that's exposing sensitive data, sensitive operations, it's probably best to narrow the scope of that access to that endpoint. So create a dedicated endpoint that does one specific thing, and then use tokens that only have access to that endpoint. Because a lot of the cases where people get into trouble here is they have tokens that have, global read and write access. They're far too widely scoped. And that's because they're hitting a common endpoint. So rather go and make dedicated endpoints for dedicated operations. And that way you effectively minimizing that blast radius. Right. So there's and I think this is going to become an increasingly important topic, as we try and minimize this third-party risk. And this is the last one, and this is a good one. This is, I think, in this week's newsletter, or it was last week's. This is a security researcher who discovered that he could access by using the vehicle's portal. So he had to have a login to the portal in the first instance, so somewhat limited in scope. But he could access the vehicle portal management portals for two different vehicles, because obviously they were using the same backend code. And he could perform remote commands, including sounding the horn or actually starting the vehicle. All right. Fortunately, in this case, it was responsibly disclosed and fixed immediately. But the damage that could be done there is almost unimaginable in the hands of a bad actor. And the issues here were two of the old ones again: insufficient input sanitization. They tried to filter an email using regex and got it wrong. And then they've had poor regular expression design, right? So a bit of bad design, a bit of bad engineering there, and they didn't test it. Right. And then lessons learned, really, if you're doing something as critical as that, then, please have some kind of other out-of-band signaling or other way to perform critical commands like that. Let's have a look at the issue. The issue originates from the fact that they're passing an access token. So they're passing in a JWT, and then they're also duplicating that data. So they pass again the user's email in the body of the request. So that looks like an anti-pattern. So what the security researcher did was he went around and fiddled with the emails, and he discovered that he was able to submit control characters at the end of the email. And then what that did was that could fool the registration portal into giving him a JWT, which had the same access rights as the original token, right? So he could effectively make his own token for somebody who was a valid car user. So he did have to know a reasonable amount of information. He needed to know the other person's email address, right? But that's hardly top secret. So, and that was the basis of the attack. So with his forged JWT, he could then access the control of the vehicle. So pretty bad one there. And again, while this is over an API, the actual issues underlying this are bad coding, bad security practice. Right, it's simply a case of I would have done absolutely, if it's doing vehicle control, do some kind of out-of-band MFA. They also had, when people did initial verification, they sent them an email, but they never bothered to validate and check that they responded to that email. Use robust input sanitization method. This is an easily solved problem. If we want to get Jim Manica on the line again, he'll talk for hours, literally hours, on the various attacks against input data and how you can do to protect that. Regular expressions are fantastic. They help solve a lot of problems. They normally create a number of problems in return. This was the case where they used a bad pattern for email testing, email validation. Any code that's as sensitive as that, as mission critical, should be peer reviewed by security experts, right? Don't take chances on that. You literally are putting people's lives at risk. And static code analysis, certainly the tools I've used would have detected poor input sanitization. Right, so really no excuses for that one. So just top ranking issues. So we had a bit of a change around from last time. Last time, I think it was both Ebola was top. This time we've got hard-coded tokens. You can see how prevalent token leakage was. There's a lot of cloak and daggers, security by obscurity, CSRF, as I said, hardly seen it before. Now we've got two in like buses, we've got two in 2 weeks, and Bola, and then a number of other issues. So bit of a change around this half of the year, and really some quite odd vulnerabilities in there. And as I've said, not all strictly relating to APIs, but more the use of APIs. So I'm sure, like everybody, I've been spending most of my waking hours this week playing with ChatGPT. If people aren't familiar with that, that's the AI chatbot. And there's been lots and lots of great posts on, well, LinkedIn's been pretty much full of people asking it questions. So I thought, let's go and help the good audience here and ask them, how do you protect against Ebola? So the first attempt wasn't terribly successful. Obviously, Ebola means something different to other people. In this case, that was not what I was looking for. So I tried IDOR, and that's the response I get. Now, if somebody asked me to define IDOR and the protections against it, I'd be pretty pleased if I came up with that answer off the bat. So so then I thought, I wonder what else it knows. And I said, how do I protect against cross-site forgery? And I think even Germanica would be pretty pleased with that explanation. And the funny thing I only noticed is I actually typed the question wrong. There's a typo in the question. And obviously it still worked out exactly what I was wanting to say. And then I asked it again about SQL injection, and that's also pretty much on point, exactly what you would do for SQL injection. So it's all rather alarming about the capabilities of this particular security context. And I think I thought to myself, I'm just going to get this chat GPT to do the next webinar, but unfortunately that's not going to be an option. It's not quite that clever yet, so there's hope for me here still. So that's let's get into the specific recommendations, because I've tweaked some of the normal guidance that we give. Threat modeling, this is a catch-all. I'm not going to go into a great deal of detail here. Some of these threat modeling things are self-evident. If you just gave the problem a little bit of thought and you thought about what would go wrong, then you can prevent a lot of pain further down the stream. Understand the use cases, abuse cases. So on threat modeling, we are working at the moment with a threat modeling provider, and we're hoping to do a webinar on this topic in the first quarter of next year. So threat modeling is your thing, particularly around API. It's something that's receiving active attention, so look out for that. And this is one I want to focus on. I said I've alluded to this a couple of times already in the discussion. So supply chains, we all know the executive order that President Biden has signed, focusing on supply chain security. Software nowadays is more assembled rather than written. We don't write apps anymore. We glue stuff together. How do we glue that together? We use APIs with their keys and tokens, and we use hyper automation with CI/CD systems, right? Nobody's going and building software by hand anymore. So those API keys and tokens, and we saw 2 really good examples, in fact, 4 good examples of where token loss or leakage or embedding of tokens can cause real damage down the line. Limit the scope and duration of those API keys and tokens. That article that I've linked to Dark Reading was in the newsletter as well, is a really, really good discussion on this topic. And what would happen here is that the recommendation here is that you do one of 2 things. So there's 2 organizations that have already done this. I think it's GitHub definitely have reduced much finer scopes in the API tokens and the lifetime of those tokens. But people are already getting wise to this, and they're starting to limit the impact of leaked tokens. Using standard libraries, components, don't rewrite your things. An example, there maybe have been a case of standard libraries and components where somebody tried to write their own email validator, right? Don't go and invent your own regex. There's people have written books on the right sort of regex to validate something like an email. Right, stand on the shoulders of giants. Use the wisdom of the commons. And also, we looked at, and we were spoiled with examples of old school stuff. The kind of stuff Jim Manico would talk about. We've got in this book, by the way, this Tangled Web is worth buying if you're at all intrigued by any of these issues about how easily web applications can be attacked, and it covers all sorts of things like input output validation, cause, same origin policy, CSRF, SRF, SQL injection. All right, just be aware that although you now on shiny new APIs, a lot of those attack vectors still exist, right? And clever people will find clever ways of exploiting them. We didn't have actually SemGrep. So SemGrep, people aren't familiar with SemGrep. Clearly, I'm a big fan. It's a semantical grep tool that is able to execute and scan source code at super high speed and has a pluggable rule set, right? And one of the rule sets there, that example is being able to capture and detect API tokens. We had 2 cases of people hard coding API credentials into code. SemGrep can find that for you in an instant, right? In other cases are dot validation errors where you're not validating your dot token correctly, where you have missing method decorators on API endpoints. So put SemGrep in, set up the rules, and get people using it. And when people come and complain about the noise that it's creating, go and refer them further on to the underlying issues and what the cause for concern is. We didn't have a case of input of mass assignment. We did have a couple of cases of excessive information exposure. Your object relational mapper, if people aren't coders, this is basically the tool that maps your input object from your coding language into a database and prevents you having to go to the necessity of writing lots of SQL queries. So it does it's a labor-saving device for developers using databases. The problem is these ORMs can have some implicit behavior that can lead to issues with data assignment around APIs. And I think what this diagram is trying to illustrate is try and put something in between, or put protection controls in between your code and your database, right? But then also go and put controls between your API and your object relational mapper, because what you don't want to do is have your ORM going and making implicit assignments for you, right? And this is a leading cause of excessive data exposure, mass assignment. And again, from 42Crunch's perspective, this is stuff that we can very easily detect at design, test, and runtime protection stage. 42Crunch, the shift left, shield right security. So secure by design, start at your design time, leverage your API contract, audit that API contract, test, and I'll make some predictions of what I think we're going to see in API security in 2023. And I think we're going to see great improvements around the integration and test, particularly about being able to test your APIs, functional, non-functional security testing, contract violation and the like, and some of these abuse cases. So I think we're going to see a big step up in CI/CD security testing automation. And then the number of cases these issues are preventable by being able to enforce API security policy at runtime. So my predictions, as I said, I think we're already seeing, I can see from the subscriber numbers to APIsecurity.io newsletter and questions that I'm being asked on LinkedIn, which is great. Greater developer awareness of API security. Right, developers are increasingly worried about falling foul to some of these common or basic attack types. Nobody wants to be on the receiving end of a security vulnerability. So developers are going to get more involved in API security, and that's driving a huge interest in training courses. We've got Corey Ball's API attacking his offensive testing course that's out. I have plans for things that we're planning on doing in 2023 around enabling developers, because just based on the volume of questions that I'm getting and the attendance on these type of webinars. So I think those will come to the forefront. We'll see some of the mainstream providers really focusing on this, the likes of LinkedIn and Pluralsight. Supply chain security for APIs, that's probably the top one for me. I think I gave a really good example there, two good examples of where API keys became the point of compromise in a complex supply chain. And this is only going to get worse, not better. And we're going to see patterns that the likes of which GitHub are using. HubSpot was the other one. There we go. I knew I'd remember it. HubSpot is the other platform that is revoking sort of old style API keys and tokens and forcing you to go much granular, right? And then platforms do this well, like Azure DevOps, you get those frequent, they don't allow you to make persistent tokens, and they continually reminding you about this. Automated API security testing, I think I know what we've got on the pipeline. It's pretty exciting being able to do much more complex API security testing. And the real benefit here is also these tests run extremely quickly. It's not DAST, not the good old days where you'd start a DAST scan and come back the next day and hope that it had finished. These execute more or less in real time, and they execute right in the proximity of your IDE. So this is exciting what we're going to be able to do. API threat hunting, I think as we are seeing more complex business attacks and we're starting to ingest API security information and logs into SIMs and SOCs, I think we're going to see security research focusing on that. And again, I've got some exciting research projects lined up with our Azure Sentinel integration in the new year. I will come to those questions in a moment. I won't do let's talk questions now. Let's do the Q&A. So I'll answer the easy one. Do you scan code, not Swagger files, but code languages? No, we don't. So we scan the API contract, which is either Swagger, Swagger or version 2, or the Open API specification version 3. We scan that, and we then make suggestions on improving that. We will, in the IDE, we will scan that code and we'll make suggestions of improving that code at design time. So an example here, if you had, what's a good example? If you had an input parameter that was supposed to be an integer and you hadn't constrained it, so you allowed people, you were expecting a positive integer and you gave it a negative, you can specify that in the contract. You can then test that when you integrate and test. So our scanner will actually go and validate that your API is handling the negative case. So A, it's handling the positive case correctly, but B, it's rejecting the negative case. And then we can enforce that at runtime. So no, so the answer there is no, we don't scan code, we scan the Swagger files. We do recommend, and I drew that hierarchy of security, API security technologies. We do recommend that you perform SAST and DAST for that matter, because defense in depth is the best practice. Static analysis will maybe find things that API runtime tools won't find, and as long as you can, the more you find and the more you understand, the better. So, is there a correlation between the technology used for an API and its security? So, kind of. Let me just explain that answer. So, there's a multifaceted to that. So newer technologies will typically be more vulnerable because they've had less research on them, they've had less attacks, they've had less incidents, people have had less of a learning a cycle to be able to understand the emergent risks. And also hackers will tend to attack new things because they know that. So typically the older the technology, probably the more hardened it becomes, right? The patterns for abuse become better understood. There's more tools in the market. So as a general hand-waving comment, I would say that, security tends to favor the slightly older and more established technologies. GraphQL, extremely powerful. But with that, and it is great, I'm thinking how I can share this. There are, in the API security newsletter, if you just go and Google apsecurity.io and you look for GraphQL, there's a number of quite thought-provoking and interesting articles that have been written about best practice and, what the issues are. Not saying that GraphQL by its nature is insecure, but a standard default implementation might be, right? So there's devil in the detail. With those advanced technologies. So I hope that answers the question. I'm being asked about CSRF, which might be, I might have to ask ChatGPT to answer that one for me. Just give me a second to read this. I understand the classic attack. So the question is the canonical example on OWASP of CSRF is that, so the terminology cross-site request forgery is that you go to bank.com and bank.com authenticates your session, passes you as the client a cookie. The malicious website, some other website, normally with a clickjack thing on Facebook or that other social media platform we're not mentioning, that will then redirect you to some evil site. So the evil.com, some other nasty website, can be a completely different rogue website, or it can be just an overlay window, right? And then they will use your session that you have established with your bank to go and act on your behalf, right? So cross-site, so it's moving you from one side to another, request forgery. So yes, it is. This is a subtle difference here. So what we're having here is we're having that the CSRF, the initial attack is that, or the initial setup to this is that you log into the console, so this admin console, log in as auth. The web UI returns you back a cookie, right, a standard cookie, and then what happens is further requests to that web UI leverage that cookie to talk to the backend API. But now what can happen is the attackers can then, by stealing that cookie and by finding some means to access the backend API, right, they can actually, if they can spoof that, normally they do that with something like cross-site scripting. So they have to be able to embed that, embed the payload, to do the evil.com thing. But then they can do access to your API that is not allowed by the web UI. So like, let's say something like reset admin password, but that might not be in the web UI. It might be hidden, but because they cross-site cross-site request forge you, they can use that API against you, but they've still got to embed that, the access vector. I'm just wondering if I'm going to have a chance to put that link in the window, because it's I did link it. If you want to go onto fortbridge.co.uk, so that's FORT Bridge, Fort Bridge. There's a great write-up in huge detail about how that works, and I recommend, if you're interested in it, you'll see what they had to do. It's not, I trivialized it, but it's much more complex than that. So I will answer that. So last takes on question. So the other question I've got here is, how do you handle not updated API documentation files? So yeah, good question. Common question. It's a process thing. So the question is, if you're basing your security model on your open API contracts, on your Swagger, and those aren't updated, then doesn't everything kind of break down because your coders might go and develop something that doesn't match the contract? Yes, absolutely. But it also presents you a number of other problems, not only security, because your documentation will be out of date, your test cases will be out of date. So first instance, yes, keep those up to date, keep those in sync. We've got patterns for being able to do round trip engineering from specification to working code and then back again to keep that loop updated. There's good tools, there's good ways to handle this, but absolutely your point is perfectly valid. If your contract and your documentation isn't up to date, then everything downstream of that tends to break down. So please subscribe to APIsecurity.io. I know many people, it's where we get a lot of our audience from. It's an industry neutral weekly newsletter that I produce. I'll be doing it the moment I get off this webinar. From the offensive side, I mentioned Corey Ball's excellent courses. I'm featuring him here again because he's got really, really good content on understanding how an attacker or how a hacker works, right? And if you are from the development mindset, go and read that course, go and look at his material, and you'll get a better understanding of what attackers are doing. And then from the defensive mindset, from the perspective of a developer, I've got a book coming out in the new year through Packet Publishing, where we talk about all the anti-patterns and the right things that you should be doing around protecting your APIs. So the question, Michael, I'm not aware of SOAP API security courses. I'm going to go and Google that. If I find something, I'll put it in the newsletter, and you can find it there. It's a good question. We do get asked about SOAP as well. And finally, events coming up. Our field CTO and co-founder, Isabel Monet, will be at, or is at, API Days in Paris at the moment. I think it starts tomorrow. And in this, February of next year, I will be looking serious and doing lots of finger pointing at the Developer Week conference in San Francisco, which is a pretty awesome event for developer-minded folk. So with that, thanks for the participation. Thanks for your attendance. I hope that's useful. Very happy to get feedback. Drop us a mail. There's numbers of ways of getting hold of us, or find me on Twitter and on LinkedIn. Connect with me, and we can continue to discuss. I'm particularly interested in knowing what the audience, what you guys want to hear more about, and looking forward to a pretty action-packed new year. So on that note, I will wish everybody a happy festive season and a happy 2023.